Exploring unknown tech, decoding future unicorns. Welcome to Product X. Using the sharp intuition of capital and the hardcore logic of an architect to help you catch the next big event in the global tech sphere. Hello everyone, I'm Rena. So here's a wild one. A startup just closed an $8.5 million seed round to launch giant mirrors into space that will bounce sunlight down to Earth after dark. The company is called Orbital, and they want to solve the renewable energy problem by literally selling sunlight from orbit. They've already tested the concept by strapping a mirror to a hot air balloon and lighting up solar panels at night. Yeah, it sounds like pure sci-fi, but apparently the numbers actually work. Vivian, want to kick us off?
Hey Rena, great to be here. So, I'm an angel investor at Pre-Angel Fund, and honestly, I've been waiting for a deep tech pitch like this for years. Space hardware plus energy arbitrage. That's the kind of insane until it's not thesis that gets me excited.
Nolan, your turn. What do you see from the engineering side?
Hey Rena, hello Vivian. I'm a former Silicon Valley architect, and I got to say, when I first saw their balloon test video, I was skeptical, but then I dug into the optics and honestly, the physics actually checks out. This is the kind of problem that's worth picking apart.
All right, let's get into it. Vivian, in the middle of a venture capital winter, why would anyone drop $8.5 million on what looks like an absolute crazy experiment?
Yeah, here's the thing. To understand this investment, you really have to look at the team's DNA and the massive energy pain point they're going after. The CEO, Ben Nowak, he was an engineering intern at SpaceX. So he's got that first principles, rapid iteration mindset baked in. When they couldn't afford to launch a rocket to test their idea, they literally strapped a mirror to a hot air balloon to prove the physics works. That's the exact kind of hardcore, can't ignore validation that top-tier VCs eat up. Now, on the commercial side, what they're really attacking is the duck curve. In California, around noon, there's so much solar power that electricity prices actually go negative. But after 7 p.m., when the sun sets and everyone gets home and cranks up the AC, solar completely flatlines. Prices can spike 5-10 times overnight. Historically, the fix was building massive lithium battery farms, but that's ridiculously expensive. Orbital's play is simple time arbitrage. They transport free sunlight from space into those 2 peak pricing hours, take a cut, and skip the battery capital expenditure entirely.
I see it a bit differently. The duck curve angle is solid, but let's talk about what actually happens when you try to bounce light from space. You can't just point a mirror and hope for the best. They're planning to put satellites in Sun-synchronous orbit, which keeps the spacecraft in perpetual daylight, while the ground below is at twilight. The problem is beam divergence. The sun has an angular diameter of about half a degree, so even with a perfect mirror, the light spot hitting the ground will be at least several kilometers wide. That right there dictates their whole architecture. You're not hitting city rooftops with a 5-kilometer light spot. You'd waste most of it. They have to target massive desert solar farms, dozens of square kilometers, to catch the entire beam and make the economics work. And then there's the pointing problem. These satellites are moving at 7 kilometers per second, unfurling huge flexible mylar sails. Keeping that light locked on a moving target requires ultra-precise control moment gyroscopes and star trackers. It's an incredibly hard engineering problem, but not an impossible one.
Wait, so the beam divergence actually forces them to only serve giant utility-scale farms? That's an interesting constraint.
Exactly, and that's the strategic brilliance. Those utility farms are exactly the ones paying the highest peak prices. But here's where it gets even more interesting for investors. VCs have poured tens of billions into battery startups trying to solve peak shaving. Orbital is proposing a complete paradigm shift. Replace chemical storage with orbital infrastructure. With launch costs heading toward under $100 per kilogram, thanks to Starship, their marginal electricity cost could eventually fall way below what it costs to mine and manufacture lithium batteries. That's a whole new playing field.
That's the commercial thesis, sure. But from an engineering roadmap perspective, they've got some huge hurdles ahead. Light pollution is going to be a battle. Astronomers are already worried because a giant space mirror is going to look like an incredibly bright artificial star from the ground. They're going to need some kind of nano-structured coating or polarization control to make the mirror essentially invisible when it's not operating. And then there's atmospheric scattering, especially for those grazing light paths at dawn and dusk. Those are the kind of physical and regulatory chasms that could slow them down before their first real satellite launch.
All right, Let's shift gears here. Quick fire round. First question, and I'm going around. Vivian, what's the one thing about this startup that would make you double your check?
The team's willingness to prove it with a hot air balloon before asking for a single dollar. That tells me they'll stretch every dollar of that $8.5 million further than most founders would.
Nolan, same question. What's the make or break engineering challenge here?
Honestly, the attitude control system. Get that wrong and the whole mission fails. Get it right, and they've opened a new frontier.
Vivian, second question. Best case scenario, 5 years from now, what does this look like?
A fleet of dozens of space mirrors serving the top 10 solar markets in the world, and utility companies paying premium for that extended daylight.
I'll go with, they've got a dozen operational satellites, and the first complaints from observatories about light pollution are already hitting regulatory hearings.
Third one. Worst case.
The mirrors never get past the prototype stage because launch costs stay high, or the pointing technology proves too hard. Another great idea that ran out of money.
A launch failure destroys the whole demo, and they have to rebuild from scratch. That's the brutal reality of hardware.
Last one. If this totally fails, what do you tell yourself you learned?
That space is still too hard and too expensive for this kind of asset-light arbitrage play. Back to batteries.
That sometimes the physics says no matter how cool the idea is.
Vivian, in one sentence, what's the takeaway from today's conversation?
Reflect Orbital is attempting to solve the oldest problem in energy with the newest infrastructure in space. And whether they pull it off or not, they're proving that the line between science fiction and venture capital is getting thinner every day.
Nolan?
The physics works. The engineering is brutally hard, and if they crack the pointing and control problem, they've essentially created a virtual battery in the sky that costs nothing to maintain.
All right, everyone. That's our episode. Thanks for joining us here on Product X. If you enjoyed this deep dive, hit subscribe, and we'll see you next time.